Circle. Similar solids. As soon as the word similarity or similar turns up, you got to be thinking fractions, ratios, and what else? And maybe proportions. So we take a look at what we have and what we need. I'm going to make 3 columns here underneath. 1, 2, 3. First one, lengths. Second one, area. Third one, volume. And we start with what we know. We don't know any of the sides or lengths. What does SA stand for? Surface area. Do we know both surface areas? Write them down. 16 inches squared over 36 inches squared. Do we know any of the volumes?
No, 104 inches.
What do you think we should put here next to this? How about an X? So I can write this for now. Inches to the third, inches to the third for my volume. Lengths, I have no idea. I don't know what my scale factor is. How do you work backwards from the area? Square root. So we have to move down the totem pole or down the evolutionary chain. What's 4 over 6 reduced?
2 over 3. Autotron.
Oh, okay.
What is this called? Scale factor. And all I know, if you look back at your other note sheets, the one that had all those words on it, this scale factor applies to anything in that top category. This could be the factor for the perimeters, the sides, the heights. I don't know what these solids are. They could be pyramids, cones, prisms. All I know is that that's the scale factor of every single length of corresponding pieces between the two. I'm not looking for this, but now I'm going to jump up to here to get the volume ratio that I need. How do you move from the scale factor to the volume ratio? What is 2 cubed and 3 cubed?
8 over 27.
27? What is that?
Volume ratio.
Volume ratio? And what was the only one that was actually given to us? This is the area ratio, and that was the one that was given. So look at the order of operations here. You started here. You had to move backwards to find your scale factor. Then you had to jump up to volume so that you'd have that. How does this help me? I still haven't determined my missing volume. Okay. You have some stuff on your desk. We're going to be going over the group work, so you'll see some videos. All this stuff has groups. Tell me what to set up.
Oh, but 8 over 27 equals 160.
Right? If you look at that column, we have a half completed ratio, and then we have a completed ratio. Some people are confusing the scale factor and the ratios down here with the actual area and volume and length. 2 and 3 are not the length of anything. They're just what everything would reduce to. 8 and 27 are not volumes. They're what the volume's reduced to. The volume is 104 over something. Hope you're feeling better. I know it's going to reduce to 8 over 27. And I know one volume is this. The other volume has to be in the same ratio. Solve your proportion. Cross multiply. Figure out x. What units? If we're looking for volume, it's 351 inches cubed. So x, if you go back to the top, would be 351 inches to the third. What happened to my information? There it is. Put it up here. Put it next to the V and see if it makes sense. This solid had a smaller surface area. Does this have a smaller volume? Yes, it looks right. At least that makes sense. Smaller surface area, smaller volume. Big surface area, big volume. Some people in my other classes, we've gone over all of this, and then I gave them a practice question. They made a proportion out of this. They just used 16 to 36 to 104. Is that what we did? No. The ratio of the surface area is not the same as the ratio of the volumes. And you have to determine it in the way that I showed you. We work backwards to the scale factor, then we work back up to our volume. Look at question 2. 3 columns. Length, area, volume. I don't know my lengths. I don't know my scale factors. Sometimes you're handed that information. Every problem is different. That's why you set up your 3 columns. Maybe you'll have this. What do I have? Which ones do I know? Write it. 1728 centimeters to the third. 1,000. That's great. I know part of my surface area. What do you want to put here? How about a variable? So actually set up that incomplete ratio. What do you think should be your first step?
Oh, you have to cube the, no, never mind. The square root, 3 cube root.
Cube root.
I can't use this because I don't know both pieces.
Oh, okay.
So I go over here. What kind of root?
Cube root.
Cube root 1728. Cube root 1000. How do you do cube roots on your calculator?
We don't have that.
Math key. In there you will see a radical 3 with a 1728. Let's do some estimation here. What do you think you would multiply 3 times to get 1,000?
Oh.
Right? 10 times 10 times 10. This is just a little bit bigger.
17.
Too big. That's a good guess.
12.
The reason you don't have calculators is because I had to mark them with a marker and they're drying right now.
Alright, at least you're a calculator. Yeah. Yes.
Can I reduce that?
Yes.
What is that? You always have to go back to the scale factor because there is no relationship directly with the area and the volume. They're both related to the scale factor but not to each other in any specific way. That's great. How does that help me?
You square it, you get the area and then you square it. You get
Yes.
So I was given the volume ratio. I then worked backwards to find my scale factor. Then I squared that to find my area ratio. That's nice, but it still hasn't gotten me my surface area yet. And I use my incomplete ratio and my newly found ratio. I will let you figure out the rest.
It's 220. Okay, can you wait?
225, what units? It's an area, it's a surface area. Go back up top, place it into your given information. Equals 225 centimeters squared. These two look like they're larger than these two, so that's consistent. At least that makes sense. Three, huh? Yeah, I cross multiplied and found that. Right? You don't have calculators, so I took care of the work, right? Proportion. Every problem is going to be different. You might have the scale factor to begin with, which will make things a lot easier. Here we had to go backwards, find our scale factor, then we had to jump up. You're only doing a couple things. You're squaring and cubing, or you're square rooting and cube rooting. And then at the end, you might have to do some sort of proportion work. Every problem's different. Everybody here knows how to read. Put that into your surface area and volume section. That's the last big topic. Everything else is a variation on what you already know.